So let's watch the decomposition reaction of ferrous sulphate. This is thermal decomposition reaction, and here we have taken our reactant ferrous sulphate heptahydrate. Ferrous sulphate exists in various hydrated forms. Heptahydrate is one among them. That means it contains 7 molecules of water in its crystal lattice. These water molecules are known as water of crystallization. Water of crystallization is defined as a fixed number of water molecules present in one formula unit of an ionic compound. So here we have taken hydrated ferrous sulphate. Hydrated means the crystals which contain water of crystallization. Here ferrous sulphate contains 7H2. We have taken the heptahydrate of ferrous sulphate. It has a beautiful pale green color. This pale green color is due to the presence of the water molecules. If we heat these crystals, it will lose this water of crystallization. That means the water molecules will evaporate and we will get anhydrous ferrous sulphate. When we heat anhydrous ferrous sulphate, it will undergo decomposition reactions to give various products. So let's see what are the products formed in the reaction and what is the nature of the reactants formed. And you should also see the state of the products formed in the reaction. Now we can start heating the ferrous sulphate crystals. As you know, decomposition reaction of ferrous sulphate is an endothermic reaction. So we need to supply heat energy. Here we have taken a spirit lamp to heat the ferrous sulphate crystals. Notice the color changes of ferrous sulphate crystals. Compare it with the color of hydrated ferrous sulphate crystals. This is a physical change. As you know, you can see water molecules evaporating from the crystals and the water vapors condensed on the sides of the test tube. This is the water of crystallization. This is a physical change. Now ferrous sulphate is becoming anhydrous. That means it loses water of crystallization. And we need to continue heating. Now the decomposition reaction of ferrous sulphate will begin. As the reaction proceeds, you can see the formation of gases. A strong stench is coming, that of burnt sulfur. This is sulfur dioxide and sulfur trioxide gases. Let's see the nature of the gases. Are they acidic or basic? So, in order to test acidic nature, we can take litmus paper as an indicator. I am going to bring a moistened blue litmus paper to the mouth of the test tube and watch the color changes. We can see the color of the blue litmus paper changes to red, slowly changing to red color. That means sulfur dioxide and sulfur trioxide gases are acidic in nature. We cannot identify the gases from their color, but from the smell we can identify, because there is a strong stench of burning sulfur. Now we can continue heating. As we continue heating, we can see the anhydrous ferrous sulphate changing into a reddish brown colored substance. It is ferric oxide. This is one of the solid products formed during the decomposition of ferrous sulphate. The gaseous products, sulfur dioxide and sulfur trioxide, have escaped from the test tube. Now what is left in the test tube is ferric oxide. So as a result of the decomposition reaction of ferrous sulphate, three products are formed: ferric oxide, sulfur dioxide and sulfur trioxide gases. Now let us examine the color changes associated with this chemical reaction. This is our reactant, hydrated ferrous sulphate, which has a pale green color. When hydrated ferrous sulphate is heated, it loses water of crystallization and it became anhydrous ferrous sulphate. Formula is FeSO4. Compare the color of hydrated ferrous sulphate and anhydrous ferrous sulphate. Now, when we heated anhydrous ferrous sulphate, it decomposes to give sulfur trioxide and sulfur dioxide gases, along with the formation of a solid residue which is reddish brown in color, that is ferric oxide. So ferrous sulphate decomposes to ferric oxide, sulfur dioxide and sulfur trioxide gases.